Greetings folks and welcome to the Electromaker Show. This is your midweek roundup of all things maker, embedded and lovely. We have a packed show this week full of projects and some things on funding websites and of course the mystery box competition, along with an update on the latest Electromaker Contest. But for now, let's get on with the show. We're going to start this week by looking at a few projects, beginning on the Arduino blog. Now, I've said in the past how much I like upcycled old radios, and this is exactly that. This is an old cassette player that has been upcycled to play MP3s, and the MP3s are triggered using RFID tags, because there's a reader in there as well. And of course, the whole thing is being run by an Arduino Nano, hence it being on the Arduino blog. But much like the old radio builds that I like, it uses the original innards, so it uses the speaker from the cassette itself. Now, this is obviously on the Arduino blog because it uses an Arduino, but it is from an instructable by the builder, and the builder is MattB138. And the instructables takes you through exactly how it was all put together. So you can see it here being breadboarded, and obviously the Nano is there in the back, and you have your RFID reader here, and this is the little MP3 player thing. It's not so easy to see there, but it's essentially, it's going to be one of these things. These things are absolutely great, by the way. They are very, very easy to get going, and essentially you just stick MP3s on a little micro SD card, and they are decoded on there and then sent in a nice, easy to play format. Now, the idea of playing MP3s off old stereos isn't that new. A lot of them are turned into digital radios, but the RFID component, I think, is pretty nice. The reader is just here, and each one of these cards, as you can see, these are just your normal RFID cards. I think he's just stuck some stuff on the top to say which one each song is, which is a great idea, actually. My immediate thinking when I saw this was to open up those little RFID dongles that you have and then stick them in between two pieces of card. No, just use the cards. They're there already. It's so much easier. But yes, the cards all have their own IDs. Those IDs are linked to songs, and then he uses Canva, which, by the way, nothing to do with this show, but Canva's kind of a fun website for making nice, quick decals for stuff. Anyway, distraction. Used Canva to make these cards, which trigger all of the songs. It's just, as I've said so many times, there's nothing in this particular project that is way too difficult, but it is a thoroughly complete project. And this that you have here is something that you make that you would be happy and you could tweak over time. My immediate thought when I saw this is exactly the kind of thing that I have done in the past, which is to take something like this and stick a very small board in there, like a Raspberry Pi Zero, for example, and turn it into a digital radio. There's still scope for that to happen. This is great as it is and can be improved upon and is a fantastic project. Also, if you are interested in just things like playing MP3s with Arduino, this is a very, very detailed write-up. I'm very kind of looking forward to following it in a bit more depth and seeing if I learn anything new myself. I will leave a link to the Arduino blog in the description because that links to the Instructables page. It also links through to the Duke RFID player, which was a inspiration to it, which is a similar project but a little bit more aimed towards the elderly, and it's yeah, they're both fantastic products. So projects. Anyway, there'll be a link to this in the description of the video. Now moving on to the Arduino project subreddit and to a completely different kind of project. This monitors the power of your whole house. And where the other one was a tutorial that told you every step of what was done, this is just a show-off piece. And it goes to show that not show-off pieces have to look particularly fancy. I've got this image here so it's a little bit easier to see. So you can see you've got the power board for the house here, and it is running out onto an Arduino with a shield. Now, I don't need to say this, I hope, but just in case, since I know there are all kinds of people that watch the show, don't mess around with any kind of high voltage if you're not 100% sure what you are doing. That includes using relays with home lamps and anything to do with actual power that comes out of the wall. Yes, there are safeguards in place in most parts of the world, but you shouldn't trust those safeguards with your life. Don't mess around with high voltage power. This person messed around with high voltage power and actually did something kind of cool with it. You still shouldn't. So the project itself uses an Arduino for monitoring, and as it mentions here, it uses the Open Energy Monitor. Open Energy Monitor is, as it says here, open source monitoring for understanding energy. Now, I've heard of this, I've never actually directly played with it. Energy monitoring is one of those things that I've always found interesting, and it's a project that is definitely within my grasp with the equipment that I have. but I've never really felt like we were using power in such a way that I needed to monitor it down to a fine grain. But I do understand that there's a lot to it, and probably if I got into it, I would really get into it. But the fact remains, it uses Open Energy Monitor along with the EMON TX Arduino Shield, which is designed exactly for this. It is designed for monitoring electricity and saying how much has been used at any given point. So yeah, there's nothing more to say about this project. There's no tutorial or anything. There's not much going on in the comments even as yet. But I just thought it would be kind of cool to show something at the other end of the scale, which is not a tutorial, and it is purely a practical project. And it is, yeah, this is home automation at its rawest. But one more time, do not mess with the breakers in your house. If you do not know what you are doing, you will die. On to the Raspberry Pi and the Raspberry Pi Project subreddit. And this is taking cooling in the Raspberry Pi to a slightly insane level. Yes, that's because this is a water-cooled Raspberry Pi 4. Now, the image alone is kind of amazing. Yeah, I do get a kick out of seeing massively over-engineered things with the Raspberry Pi. Now, this isn't the first water-cooled Pi I've seen, but it's definitely the coolest. There is a video documenting the entire thing as well, by the way. This is by Michael Clements. I will, as always, not show you the whole video. I won't go through every detail of what is covered in the video. I will tell you that this, not surprisingly, works very, very well. The Pi at full load, overclocked to 2 gigahertz, was only running, well, it was running below 40 degrees. I can't remember exactly. I think it was around 38 degrees was the max temperature, running full belt at overclocked at 2 gigahertz, which is sort of amazing. And as always, people tend to think alike, because I saw this and I watched this video, and then I thought, I wonder if you could use this same cooling system to make a cluster of incredibly overclocked Raspberry Pi 4s. And of course, someone has already asked this in the Reddit comments, and that's exactly why the kit was bought, working on a water cooler cluster at the moment, which is going to be sort of amazing. So yes, I will leave a link to this Reddit post in the description, because that has all of the comments I've just been talking about, along with a video link from Michael Clements himself. And if you want to follow him on Reddit, he is user M Clements with a K. But yes, you can find all of this from the link, which will of course be in the description of this video. And now a project that isn't new. In fact, it is 10 years old, but it just showed up again in my feed this week and I had completely forgotten about it. This is the Pi60 Project, which is a build of Python which works on the old Nokia S60 phones. This Adafruit post reminded me of two things. One, that Python on the S60 did actually exist. I wasn't really someone that would be 100% interested in that side of things at that time, but it did exist. But it also pointed me to this Twitter thread, which I just find incredible, that I didn't know that there was a build of Blender or something like Blender that worked, on the S60 version 2, which is sort of amazing, really. Look at this. This is like, you wouldn't feel bad looking at this if this was a textured PlayStation model. In fact, it's probably better than models for the PlayStation. It's fantastic. I think this is just a wonderful thing. So I will leave a link to the Adafruit article in the description of this video, because there's a lot of Twitter diving you can do here to find a lot of crazy old stuff that people do with old Nokia phones. And of all of the technology I've gone through over the years, I still have an old Nokia 3310 sitting in a drawer back in my old home that I grew up in England, because I can't quite bear to get rid of it. And now moving on to something that you know I am very excited about. This is 3D printed MIDI controllers for creating music on your computer. Now, we talked about something not dissimilar to this on last week's show, but this goes in a much more DIY direction. This is 3D printing an entire set of MIDI triggering devices. Here they are, and they look beautiful. And I'm going to leave this image up for a second just while I go over MIDI. I'm sure most of you are familiar with it, but MIDI, or Musical Instrument Digital Interface, is it's a technical standard for speaking to musical instruments. And at its rawest, at its simplest, you send a MIDI instruction to a synthesizer or computer or whatever, and that is changed into sound, and there can be timbre information in there as well. There can be velocity information in there as well. Basically, if you imagine pressing a piano key and you expressed the pitch and the volume, and you know those, well, with the piano key I guess it would be only those two, and then sent that to a digital synthesizer, then it would know what to play. Now, why are there so many modules here? Well, when you know that you just have to send a digital signal to something to make it work, then you can start sending chains of digital signals that you prepare in advance. And that is what all of these little Arduino Pro Minis are doing here. I did it again. No, look, Pro Micro. One day I will learn the difference between Pro Minis and Pro Micros. It's terrible. So yes, this is a wonderful project. This is a Leet synthesizer, yeah, as you can see, there's a whole bunch of them that do a bunch of different things. It is an entire series of stuff, and it is all completely 3D printable at home. Now, using the Pro Micro to do things like this is not new. People have been building their own MIDI controllers for years using similar USB HID compliant devices. I have in fact tried a couple of these kind of things myself, and as I mentioned last week, I'm kind of tempted to try doing something similar with one of my old MIDI controllers, which now doesn't really work anymore. But yeah, this is good enough as it is. This is such a nice idea that it's easy to follow, printable parts that allow you to create MIDI controllers, which all will work with, yeah, as I said, digital synthesizers or any DAW. I use Ableton, but of course there are many, many others. You don't even have to necessarily pay for them. There are some great open source digital audio workstations out there. But I haven't got on to the coolest thing about this. There's one thing about this project that is absolutely just breathtaking to me. I think it is such a clever idea. That is, there's no PCB here. The circuit board is 3D printed. So that way you can just route your wires from place to place where they need to be, and you don't have to actually have a PCB printed and get one sent to you. That means that there's nothing to be sent out. You can completely just order the parts and print this at home. You don't need to buy a kit from the creator, and yeah, you don't need to get a PCB printed and sent out to you. Yeah, I mean, I don't know what else to say. That to me is, I've not come across anything quite like this. Obviously there's a lot of breadboarded stuff which uses wires like this, and when you're using perf board, you're going to run wires around to create your own PCBs, but to integrate it into a 3D print like this is something that I find super clever. So yes, the hardware side of this is super impressive, and as you can see by the way here, you don't necessarily have to use a computer or a digital synth. You can use a smartphone because they're more than capable of creating quite decent synth tones these days. And the 3D printed circuit board idea is something that I find really interesting too. One other point about this, which is nice, is that all of the source code is completely open source. And there are so many people out there who are working with MIDI using Arduino that I imagine that this source code will get very, very robust in time. So I will leave a link to this blog in the description, and yeah, I've talked about how much I love this. I'm not going to go on about it anymore. There is a lot to this, and of course there is the plans so you can make your own. I am very, very tempted to do so. I have everything I think that is needed to make this, other than possibly a few Pro Micros that I would have to get. And if I do, I will of course feature it on the show. But for now, head to the link, which will of course be in the description of this video. Moving on to a tutorial that I found quite useful this week. Now, I've mentioned several times that I want to make some improvements up here in the Attic of Dreams and a few in the flat below, namely just to do with lights and some smart power sockets, but I could just buy those or I could make them myself. And I'm quite fond of these little ESP8266 boards. This is a Node MCU, which is basically just a breakout board for the ESP8266 with a little serial module on it. Now, these are great. But for example, if I was to stick some lighting behind our sofa and the box was down behind the sofa somewhere, I don't really want to have to dig it out and stick a USB cable into it every time I want to reprogram it. And that is where the ESP32, the bigger brother to this, comes in. So ESP32 modules are capable of over-the-air programming, which is exactly as it sounds. You don't have to plug it into anything to program it. As long as it is powered on and connected to the internet, you can send things to it and reprogram it. It's actually a surprisingly simple process. I hadn't really looked into it in the past because I assumed there'd be a lot of faffing around to do, but I discovered this tutorial on lastminuteengineers.com, which takes you through step by step how you can set up OTA. And basically, as long as you have the OTA sketch on your Arduino, including the OTA header, then it will work. The very important thing is that you don't upload a sketch without it, because of course then it will not be able to receive new things over the air. But it was actually surprisingly simple, and I was able to get my little ESP32 board to blink at various different speeds when it was just plugged into a battery pack on the opposite side of the room. Now, of course, there is a caveat here. ESP32 dev boards are a little bit more expensive than ESP8266 boards, but I'm not going to be using them absolutely everywhere. I just thought it was kind of a handy thing for ones that are maybe going to be a little bit further away and hard to reach. Now, as always, as with almost all these things, this Last Minute Engineers tutorial is fantastic, and I will be leaving a link to it in the description. As you can see down the side here, there are actually several tutorials that they have put up about the ESP32, and I look forward to reading through all of them. Yeah, whenever you even approach something like this, you have to always check Andreas Spies, and he has, of course, got a fantastic tutorial on OTA. And not only does it tell you how to do it, it tells you a little bit about how it works. And as with each one of its videos, it is fantastically presented. So you can always go and look at this as well. But if you are interested in the ESP32, they are pretty cheap these days, and there's various form factors you can get. I'd say messing around with them would be a kind of decent idea. They're pretty powerful little beasts. You can attach cameras to them. They can even do basic object recognition. I need to spend a little bit more time with the ESP32, I think. Now moving over to the Arduino subreddit with an Arduino-powered watch. And when I say Arduino powered, of course, I mean ESP32. This is the LTGO smartwatch, and it's based on the ESP32, has a 240x240 touchscreen, a vibe motor, a speaker, along with Wi-Fi support and various other things. This video here shows a basic tic-tac-toe game, and if you click through on the Reddit comments to the YouTube channel that is showing this, it is Volus Project. Now, we've featured Volus Project on this channel before. Volus Project is the same person that came up with the Calcuino, which is the do-it-yourself Arduino calculator, which I thought was just a very simple and lovely little project. It fits so many boxes for me. This is the LiquidCooled LTGO Watch. Now, this isn't a project that he created. You can buy these things online. But the thing about it that I find is kind of interesting is that these things are really just a completely open development platform. You get these things and you're going to have to kind of learn how to work them, because essentially this is just an ESP32 and a touchscreen and a few peripherals inside a watch. It's not a watch, really. It's a development board that sits on your wrist. And not only that, they are pretty cheap. $21 on Banggood is the one that I turned up right now. I'm sure you could probably even find them slightly cheaper than that. And yeah, you're going to have to do a bit of work if you want to get this thing to do anything. And I love that. I love the idea of buying a watch that you have to turn into a watch. I'm sure it does come pre-flashed with some kind of watch face or all that kind of stuff. But that's rubbish. You have to make your own. Those of you that watch the show know me and know that I am quite an impulsive person. And yes, one of these might already be on the way to me. But I did say I was going to get more ESP32, so it's allowed. It's allowed. Anyway, as with the last Volus Project video, this shows you essentially what he's done with it and how he did it, going through some of the code in the Arduino interface as well. As always, it is a great video, and I will leave a link to the Reddit thread in the description of this video, because that has all of the comments and the person that posted the video talking in there, along with a link to the video. And if you want to find the code for the games that he put on the watch, that I will just zoom back to that again because it is rather cool. If you would like to find the code for these games that he created for his DIY smartwatch, you will find them all in the description of the video as well. Back to the mystery box competition we go. Now, it is a mystery box. I pull things out of it and people win prizes. There's a piece of plastic on the top here too. That's kind of it. And this is the prize, and it is from Seed. It is a Linkit One. It is a Linkit One Ultimate Development Kits for Wearables and Internet of Things. Feature. Ooh, okay, this looks pretty cool. There's a 32-bit ARM Cortex chip, onboard Bluetooth, micro SD card slot, audio out. Ooh, audio out I find interesting. Oh, this is familiar. I feel like we may have given one of these away already. So yeah, this is the board. As you can see, it has an Arduino compatible header space on top of it. Underneath here is where the system on chip is, and as I said, that's a 32-bit ARM Cortex chip. Micro SD card slot, and as mentioned, a 3.5mm out for audio. This thing looks pretty cool, but as always, I'm going to go and have just a very quick look just to see exactly what it is. Okay, so having quickly looked it up, this thing is super cool. This is a 32-bit ARM Cortex chip, as I have said, and not only is it Arduino Shield compatible, there is a plugin for the Arduino IDE allowing you to program it with the Arduino IDE, which I know for some people makes things a lot easier. If you've only used the Arduino IDE, which was me until relatively recently, other ways of programming things can be a little bit challenging. The other cool thing about this is it comes with a LiPo battery, which fits to the board, along with a Wi-Fi antenna, a GSM antenna, and a GPS antenna. There is a lot of things you could do with this little development board. It is a very nice thing. But anyway, we have a prize, and now we need a prize winner. And through the power of selecting a random range on a spreadsheet, we have a winner for this week, and I couldn't be happier because the winner is Wrench. And according to the comment on the video, Wrench is the person that made the Watch Dogs beeper in last week's Electromaker show. I could not be happier that this thing is going out to you. What a fortuitous thing. And I hope that you make as many cool things with this as you started making with the other stuff. If this is Arduino IDE compatible, you probably already know how to use it, and there's a lot of stuff you can do with it. So I really do hope you enjoy this, and we'll be in touch with you as to how we can get this thing out to you. And as for everyone else that left a comment on last week's video, thank you so much. As I say, everyone's entered into the mystery box competition regardless, just every comment is put in there. This kind of stuff, this kind of fortuitousness makes me very, very happy indeed, and it makes me realize that this show is perhaps doing some good in the world. So thank you. Anyway, enough waffling from me. Let us get on with the rest of the show. Moving over to some funding website things, and we're going to begin on CrowdSupply with the Stereo Pi version 2. Now, the original Stereo Pi was launched on CrowdSupply, and it is a stereoscopic camera hat which is designed to sit on a Raspberry Pi. The original Stereo Pi used the compute module. I think it's every compute module up to the compute module 4. It doesn't particularly matter. This is the older one. It made great use of the fact that it had stereo cameras, and you could just use the edge connector to slot the compute module in, as you can see here. And the second one appears to be doing much the same, but with even more functionality. Now, there's a lot of new features that the Compute Module 4 brings, and they have updated the hat in order to make the best use of that. And I will allow you to read this yourself to get through all of them, but to my first glance, the most exciting thing about this, of course, apart from the fact that you're going to have very high-quality stereoscopic camera imagery using very cheap parts, is the fact that the camera lines are hackable. There are 0-ohm resistors running across the I2C bus, which is a little bit above my grade of electrical engineering, but I do know that that allows you to basically control it in different ways. If there is someone out there who's a little more familiar with all that kind of stuff, and you would like to point me in the direction of a few resources about that, I'd be super happy to. It's right at the edge of my knowledge at the minute. The original Stereo Pi was a massive success. I have no reason to think that this one won't be. It has not launched on CrowdSupply quite yet, but the last one, as I say, just did very, very well. And these are really inventive boards. It's a really nice way of using the Compute Module 4. And of course, if you want to use it in an industrial environment, the Raspberry Pi 4 is able to use eMMC onboard storage, which is very stable and has a lot of space. So I don't think you'll just be using it for pointing it at lakes. I imagine that people will be using this for DIY industrial purposes as well. If you want even more, there is a blog post which tells you the entire development story of Stereo Pi 2, which I have not had the chance to read yet, and I will be reading this later on instead of my book when I go to bed. Because this is a fascinating project. When it goes live, I will be sure to let you all know, but for now, there'll be a link to this launch page in the description of the video. Next, staying with CrowdSupply, an open-sourced Arduino-powered 3D printer. Now, that doesn't sound like anything new, but this is a resin 3D printer. Yes, the Light 3D printer is an Arduino-based open-source MSLA printer. Now, MSLA, if you are not familiar, is one of the many ways you can do resin printing to make it very, very simple indeed. Basically, you have a very strong light underneath a masking LCD screen, and the masking LCD screen will make one little shape, and the light will shine through, and that one layer will become cured. It is exactly how this 3D printer you can see in the background of this shot works, and they are fantastic. The model quality you get out of them is unsurpassed, and despite the fact you have to mess around with isopropyl alcohol afterwards and cure them in UV light, it's a bit of a process. My experience with resin printing has actually been more positive than FDM thus far. Anyway, back to the thing itself. This is a tiny little resin printer that you can build yourself. It uses Arduino, and as it says, MSLA technology. But this is the first of its kind based entirely on an Arduino board, which is but no, this is a fantastic project. I am very excited about this one. I wonder how much it will be they're asking for to make it. I wonder how much they will cost. I wonder how open source it will be. I have so many questions. But you can see that for something that you build yourself, the print quality isn't actually all that bad whatsoever. It says here that it has a resolution of up to 0.4 millimeters in the XY and a Z resolution between 0.05 and 0.1 millimeters. And uses less than 4 watts of power. That's actually kind of cool. But there we go. It is a fully open source project. That's just what I was about to come on to. That's kind of amazing. Open source software, firmware, hardware, 3D printing files, and user guides will be available soon on the Elite3DP website. So this ticks all the boxes for just a wonderful little project. I will be coming back to this one for sure, and there will be a link to it in the description. And I just noticed down here at the bottom, something I had missed before, the fact that it is open source and that they have their own website that you can go to as well. And now moving on to Indiegogo, which is a site that we haven't really featured on this show, and there's no real reason why not, I guess. Just usually by the time I've looked through Crowd Supply and Kickstarter, I found enough things that I'm excited enough to talk about for the week. But this is on Indiegogo, and this is something that's causing a little bit of a stir this week. It's not directly sort of maker, but it's maker adjacent for sure. And that is the Pantera Pico PC. Now, it's a 2.3 gigahertz J4125, and that is an Intel chip. It is a Windows 10 and Linux box, but it is absolutely tiny. It is a lovely little beast indeed. But yes, the main draw of this thing is its size. It's 2.6 by 2.6 by 1.75 inches. Now, this is like tiny. I don't think I've ever come across an x86 computer that is this small. I have so many questions about this. I don't know exactly how they've done it. How do you fit something so small into that? But anyway, there's not much to this at this stage. This is also a pre-launch thing. But the size of the computer is one thing that is definitely worth thinking about. The fact that it has a fair amount of ports on it is worth thinking about, as well as the micro SD card. There are 3 USB 3 ports, a USB Type-C port for power and HDMI out, a headphone jack, and a normal USB 2 port. But there's another side to it which I really, really like. And this again just pushes it from being like interesting into something that's like super interesting, and that is the fact that it has a dock. Yes, these are obviously generated images. There's no image of the dock yet, but you can sort of see what is going on here. The idea behind this dock is it will be an extra power bank, and it will also be a speaker. And I almost feel like they want this computer to be something you can keep in your pocket, and it is a fully working computer, but you can also plug it into the dock and use it a little bit like a portable music system, perhaps. There's a lot to this. There really is quite a lot to such a small, tiny thing. So the Indiegogo page doesn't have much on it. I've showed you most of the text, and there's this video as well. And this is the part where I should remind you that it doesn't really matter what funding website you're on. You should always take some of it with a bit of a pinch of salt. Especially funding websites where the money goes to the people regardless of whether they meet their targets or not. You have to put a little bit of trust into them, because one thing you may have noticed looking at these is that these are just shells. There's nothing inside them. These are not computers yet. Now, I've got no reason to believe that people would go so far as to make shells like this of a computer just to try and scam people out of their money, but mistakes do happen. It might be worth waiting a little while to hear some updates on this. But from what I've seen, it's enough to get me kind of excited, and I will be coming back to this to get a kind of broader view of how this might work and how it might all fit together. So I will leave a link to this Indiegogo project in the description of this video, and as with all things on most websites, you can sign up if you want to get more information on it. But I'll be following this one quite closely because yeah, there's a lot to be said for small form factor x86 computers. I have an Atomic Pi, which is exactly that, but it isn't exactly user friendly either. You can't even power it on without actually directly powering the GPIO pins, which doesn't really bother someone like me, but I can imagine there are people out there who would want a small form factor computer like that wouldn't necessarily find that so useful. But yeah, we'll come back to this one later. And if any of you out there are fans of small form factor fanless x86 computers, please do speak up in the comments, because I am actually looking into getting a second machine for the flat, which doesn't have all of the bells and whistles of this one, which I can just sit in a corner and use yeah, for similar things that I imagine they want to use this one for. So just a couple more things before we end the show. Firstly, a quick update on the latest Electromaker Contest, which is the Great PSOC6 Challenge. Now, this is a contest we're doing with Cyprus, and it is to do with 4 of their development kits, but they're all based around the PSOC6 chip, which is a system on chip. I've written about them on the Electromaker website. I've talked about them on the show a little bit before. It is a pretty powerful chipset, which can do quite a lot of stuff. But the design challenge essentially was you have to design projects, and the best projects will be selected and they will get hardware. And that process is now done. The best projects have been selected, and the people who have won that have been notified, and they will be getting that free hardware sent out to them soon. And that is a mixture of these 4 different development boards. There is the Pioneer kit, which has a TFT display. there is the BLE Pioneer kit, which has an e-ink display, along with the Wi-Fi prototyping kit and the BLE prototyping kit. Now, I have had my hands on all 4 of these boards to write about them and to mess around with them just a little bit, and I was quite happy with how easy it was to get up and running with them. Modus Toolbox, which is based on the Eclipse IDE, although you can do it all from the command line using their command line commands as well if you want. It works both ways. I've fiddled with both, just with very basic hello world stuff, haven't dug too deep. But if you are familiar with microcontrollers that are maybe really one step above your Arduino IDE microcontrollers, you will have no problem with these. Now, just because the people who are getting free hardware have had their free hardware selected and will be getting it sent out to them does not mean you cannot take part in the competition. After all, there is a £1,000 pounds? Who am I? I'm supposed to be speaking in American right now, I apologize. $1,000 prize, and the second and third prizes are $500 each as well. If you still wanted to take part in this, the Pioneer kits are $80, which seems like quite a bit, but you do get quite a lot with the kit. However, at the other end of the scale, the prototyping Bluetooth Low Energy boards are only $16, 16 euros and 94 cents. Switching between currencies is hard. And out of all of them, I think I probably had the most fun with this one, just because I could leave it hanging out of my USB port. And basically, you just have your very familiar. This is your normal development board setup. You have all of the GPIO pins, headers on the side, which feed into the PSOC6 chip. And over here, you have a programmer, and this is the Kit Prog 3 programmer. And of course, as you can see here, there's a little bit that you can snap it off if you want, and then reattach the programmer via headers later. All 4 of them work using the same technology. It's all PSOC6. But if you still wanted to take part in the competition and maybe learn about a new architecture as well, this board, just for reference, this board that I'm talking about here is the bottom board on this contest page. So if you are interested in it, head to the Electromaker website and click on contest. It will come up as the top contest. I just wanted to let you know that this contest is moving along now. If you are one of the people that designed something that we thought was worth sending out free hardware to, congratulations, you'll be receiving it soon, and we're all very excited to see what you come up with. And finally this week, something that is decidedly not as DIY, but it got me thinking, and I thought it might be something that you would find interesting as well. This is the fact that Nanoleaf are bringing out their own basic smart lights. Now that in and of itself isn't that exciting really. There are a bunch of smart bulbs out there. Philips Hue are probably the most popular, and they all work on a similar thing. They're color changing, and they are usually attachable to via some kind of low energy Wi-Fi signal, sometimes through just general Wi-Fi, sometimes through Bluetooth. Now, Nanoleaf is a name you might find familiar because they make these rather fancy and very, very expensive, but still cool wall panels. They had a kind of rise to power. They had a very successful funding campaign, I think, back in the early days, and are now stocked by the Apple Store and supported across all Apple devices if you're into that kind of thing. Now, the reason I wanted to talk about them is not because of the things themselves, not that I think they're bad particularly. I've covered this week, and the spec for them is actually pretty good. But the thing I find interesting is that they're using the Thread protocol. Now, a lot of these in the past have used Zigbee, and Zigbee is sort of, people are kind of saying the old name in like meshed together Internet of Things Wi-Fi stuff. I don't think that Z-Wave is ever going away because it's so ingrained into certain things. But anyway, people are sort of saying it's a bit old and a bit outdated. Thread is the new thing. Thread's been around for a while, but it's only starting to find its way into consumer items now. But why am I talking about this on this show? Well, Thread is inevitably going to get bigger. The fact that Nanoleaf have brought out their Essentials line on Thread, which is supported by Apple, people that use Apple HomeKit and the Home Mini speaker, I don't really know Apple products all that well, will be able to use Thread. And as far as I know, they're the only people that support it now, but it will be getting adopted in a wider fashion. How is that interesting to people like us who like to program little microcontrollers to flash and beep? Well, that is because the NRF5 SDK, which is the software development kit for working with Nordic Semiconductor's NRF5 chip-based development boards, supports Thread and Zigbee, best of both worlds. I just kind of wanted to point that out. I think we've given away a few things based on the NRF5 chip on this show, and also we covered the new Microbit, which is the, in case you're not familiar, it is a development board aimed at children and education. However, they also come stocked with NRF5 chips, I believe. I don't have the specs in front of me. So they're fairly widely used, and the fact that they are capable of working with Thread and Zigbee is something that us DIY should probably be abreast of for the future. And if you are interested in learning about Thread, specifically with the NRF5 series of boards, there is a very, very detailed and long tutorial that I found, which uses a development board that I don't have. It doesn't particularly matter. Don't actually plan on doing this anytime soon, but I would like to know about it. And yeah, this is a good read. It takes you through it in very, very small steps in ways that makes it very easy to understand if you've never used a protocol like Thread or even Zigbee. Not all that familiar with using it hands-on, I just know what it is. This is a great tutorial. This will be in the description of the video, as will the SDK page. I'm not going to bother putting the Nanoleaf website in the description of the video. I'm sure if you are interested in buying new Nanoleaf bulbs, of which, by the way, I have bought a couple. I'm interested in seeing what they're like, and for an easy solution for the top lighting in this room, yeah, Wi-Fi enabled bulbs, why not? Let's just try them. If you want Nanoleaf, you can find Nanoleaf, I'm fairly sure. This is the interesting part. NRF5 Thread. If you are someone who's used Nordic stuff in the past and you are familiar with how all this kind of stuff works, shout up in the comment section. I might want to pick your brain about this. I just wanted to say this is kind of interesting, and this is one of those things that maybe learning a little bit about it now will make things a little bit easier in the future when Thread inevitably takes over and Zigbee dies. It's not going to happen. That was the Electromaker show for this week. Thank you so much for joining me. I hope you found it informative, and if there was anything in the show that particularly caught your eye, let me know in the comments. If you see anything randomly in the internet during the week that you think might be a good thing for the Electromaker show, please do drop a comment on the channel. But for now, I hope you have a creative and healthy week, and I'll see you next time.